So I'll just quickly introduce Bridget. So most of you know Bridget. She's been PhD student in our lab for more than a year now after having finished her honours degree also in the lab. So she's been working away on a project that links in with our larger ARC funded Square Eyes project. And she's been doing some great work, especially as it comes to how we measure and things like that. So she's going to tell us some of the things she's been working on and her plans for finishing her thesis off. So that's all yours, Bridget.
Thanks, Taryn. So I'll just share my screen. Alrighty. So hi everyone. My name is Bridget, and today I will be going over the progress of my thesis so far. So my research is looking at the methodology used in screen use research with a focus on the impact of screen use on children's sleep. So in this presentation, I'll go over some of my results from my first study, which is a systematic review on the use of wearable cameras to measure health behaviours in young people. The findings from this review will lead on to my second study, where I'll be evaluating the validity of wearable cameras to measure children's screen use. In my third study, I'll be evaluating the validity of an accelerometer algorithm to measure children's sleep. And then in my fourth study, I kind of want to bring this all together and use these validated measures to look at the impact of children's screen use on sleep. So to have an understanding of how my first study relates to the methodology used in screen use research, I need to give you a little bit of background on the limitations of screen use research and how wearable cameras kind of fit into this. So screen use research is limited by two main factors. First, there is currently no gold standard measure for screen use. So most research is based on self or proxy reported unvalidated questionnaires. And these measures are prone to bias, are unreliable, and they're also often outdated. So they don't take into account the newer types of devices. The second limitation is that most of these measures lack precision. So they measure total screen time, and they don't often take into account the type of content or context of children's screen use. So for example, they don't take into account if the child is watching an educational program versus an entertainment program, or if the child is watching television alone or with a parent. And these factors have been shown to have different effects on children's outcomes. So wearable cameras have the potential to overcome these limitations. So these cameras are typically worn on the chest and they take first-person point of view images at fixed intervals. So that's similar to your time-lapse feature on your smartphone. And these cameras have been used to explore a range of health behaviours in adults and children. So these cameras have been used to capture physical activity and sedentary behaviour in adults, dietary behaviour in adults and children, food marketing exposures in children, and travel methods to school. Here's an example of two images taken by one of our cameras at the lab. So you can see here that wearable cameras are able to capture the content, so what's on the screen, and the context of children's screen use. So we're able to extract data from these images that previous screen use measures have not been able to measure. However, just because a measurement looks feasible, it doesn't mean that it's valid or reliable. So when I refer to validity, I'm referring to the accuracy of the measure. So does it measure what it intends to measure? And when I refer to the reliability, I'm referring to if the measurement is free from measurement error. Now in wearable camera research, we focus on inter-rater reliability, which refers to the level of agreement between image coders when coding the images captured by the cameras. And it's possible for a measure to have high reliability, but poor validity, and vice versa. So given the importance of improving the quality of the current screen use measures, it's important we both consider the reliability and the validity of wearable camera methods. And this is what I want to look at in my systematic review. So the purpose of my first study was to provide an overview of the current evidence on the use of wearable cameras to measure health behaviours in youth. So in this review, I wanted to identify which health behaviours have been measured by wearable cameras, describe key procedures, and I wanted to look at the reliability of and validity of these measures. So to be included in this review, our studies had to have a sample with a mean age between 5 to 18 years old. They had to measure one or more health behaviours using a wearable camera, and they had to report qualitative or quantitative findings. And studies were excluded if they used active image capture, which is when the participants had to take the photos themselves. I developed the search strategy based on an objective approach, developed by Hausner. So I did this to minimize the chance of bias in the development of the search strategy. So to do this, I conducted a prelim search in the databases to identify relevant reviews and articles on wearable camera research. In this study, I screened 83 articles and identified 23 relevant articles. I then conducted bidirectional screening using those articles. And at the end, I had a total set of 29 articles. So then I randomly divided these articles into two sets. So a development set and a validation set. The development set was then entered into a word frequency software package. And I used words that were at least in 20% of these articles to develop the search strategy. So my first draft of the search strategy found 13 out of the 14 articles in the development set. And then once the search strategy was able to find all of those articles, I tested the search strategy against the validation set. And the final search strategy was able to find all the articles in the validation set. So then I adapted that search strategy for each database. And these are the databases I conducted my search in. I also searched 3 trial registries. I searched the reference list of the included studies, and I also contacted the included authors about their knowledge of any additional articles that I might have missed. So here's a picture of my Prisma diagram. So after duplicates were removed, we screened around 9,000 titles and abstracts. And then we screened nearly 200 full text articles, and then had 20 articles that were included in the review. And this is what our main findings were. So we found that wearable cameras have been used to explore a wide range of health behaviours in young people. So the most common health behaviour wearable cameras assessed was dietary behaviours, followed by sedentary behaviours, which included screen use and reading. We also identified other behaviours such as sun protective behaviours, exposure to smoking, travel methods to school, physical activity, and other activities of daily living. However, we found limited research on the reliability and validity of these measures. So we found that only 7 studies reported the reliability of wearable camera measures. As we expected, the only type of reliability assessed was the inter-rater reliability between the coders for image coding. So 4 of these studies assessed the inter-rater reliability for dietary behaviours. 2 studies assessed inter-rater reliability for sedentary behaviour. And 1 study assessed the inter-rater reliability for travel behaviours. And we found that all of these studies demonstrated an acceptable inter-rater reliability, which shows promising results. So while there was limited evidence, the limited evidence kind of does suggest that it may provide a reliable measure for different health behaviours. However, but we did not find any studies that assessed the validity of wearable cameras. So 2 studies that were included used wearable cameras as a proxy for direct observation to validate another measure. However, none of the included studies evaluated the validity of the wearable cameras to measure the health behaviours. In our review, we also found some other interesting findings. So we found that the different camera placements may be more optimal for catching different behaviours compared to others. So we found that the camera positioned on the chest was better at capturing sedentary behaviours, while cameras at collarbone level were better at capturing food marketing exposures. And this was because the different health behaviours required different camera angles. We also found that the height of the participant also influenced the field of view of the camera. And we found that researchers also need to consider the type of health behaviour they want to measure. So images became blurred when participants moved a lot. So it looks like the camera might be more suited to capture health behaviours that involve minimal movement, like sedentary and dietary behaviours. We found 2 main limitations across the included study. So the first one is that majority of the included studies had smaller sample sizes. because they were, majority of them were feasibility or pilot studies. So that also might explain why there was such little research on the reliability and validity of these wearable camera measures, because a lot of the reliability assessments were taken as part of the study quality checks, and few studies actually purposely assessed the reliability of the camera measures. The second limitation we found was that there is actually a lack of consensus on the reporting of variables and the coding methods used. So some variables we looked at, such as wear time and image coding procedures, were inconsistently reported, or they weren't reported at all. And each of these studies also developed their own image coding protocols, and a lot of the coding protocols differed despite them trying to code similar behaviours. So to kind of summarize the findings and how these findings kind of apply to the research. So we found that wearable cameras may provide a reliable method for assessing some health behaviours in young people, specifically diet and sedentary behaviours. However, there is limited evidence, and future research needs to look at evaluating the validity of wearable cameras. Researchers need to also consider several factors when using wearable cameras in young people, including the camera placement, the participant's height, and the type of behaviour they want to capture. And finally, future research needs to focus on creating best practice reporting and coding standards that can be applied across the multiple health behaviours to ensure that there's more consensus throughout the field. So to give you a quick look at my timeline for this study, so I finished data analysis and I'm now up to writing the manuscript for the review, which I hope to submit by the end of this year. So the results from my systematic review then lead into my second study. So in this study, I want to look at the validity of wearable cameras to assess children's screen use. And this study and my study 3 will use the same sample. So in this study, I want to investigate if wearable camera measurements of children's screen-based behaviours is similar to direct observation measurements. And to do that, I'm going to recruit 30 participants aged 8 to 11 years old. So I'm going to collect basic demographic information such as height and gender and age and weight, sorry. And then I'm going to assess the validity of the camera measures through an observation session. So the participants will be asked to wear a camera on a chest harness. And while the participants wear the camera, a trained researcher will directly observe the participant. So this observation session will be 2 hours long and will be split into two 60-minute sessions. So during the first 60-minute session, participants will be asked to complete 6 randomly assigned screen-based behaviours from a list. So an example of one of these behaviours is watching an educational program while eating a snack. During the second 60-minute session, participants will be asked, won't be asked to do anything, and they'll be free to do whatever behaviours they want. And then at the end of the observation period, researchers will conduct a 5-minute content recall interview where the participant and the researcher will review the images that were captured just to confirm the content that the participant was viewing. So I'll compare the wearable camera data and the direct observation data. So each method will record the type of device being used, the location, the social environment, and other related behaviours such as eating. I will then compare the wearable camera data with the content recall data. And then this leads on to my next study, where I'll be evaluating the validity of an accelerometer algorithm to measure children's sleep. So similar to screen use research, sleep research in children relies heavily on subjective measures. So a recent systematic review looking at the association between young people's screen use and sleep outcomes found that 98% of studies included in the review use subjective measures for both the screen use measure and the sleep measure. And other reviews have found similar findings, where majority of the studies relied on self or parent report for both screen use and the sleep measures. So to improve our understanding of how screen use impacts children's sleep, we also need to improve the way sleep is measured among children. And one way to do that is by using accelerometers. So accelerometers have been used to estimate movement behaviours, including physical activity and sleep. So these are typically worn on the hip or wrist. And how they work is that they use accelerometer sensors to estimate the intensity and frequency of movement. So these signals produced by the accelerometer are then interpreted using a scoring algorithm, where they can be processed into relevant movement components, which include sleep, sedentary time, light physical activity, moderate physical activity, and vigorous physical activity. So these devices each have their own unique scoring algorithm. So to detect sleep, most algorithms for wrist-worn accelerometers rely on the magnitude of acceleration of the arm. So low magnitude indicates sleep and high magnitude indicates wakefulness. However, these methods don't allow you to compare data across the use of different devices. Instead, I'll be looking at the validity of an algorithm developed by Van Hees and colleagues. So their algorithm uses accelerometer-derived arm angle to detect sleep. So this uses raw accelerometer data to identify periods of sleep and can be used with any model of accelerometer. So this algorithm has been validated in adults and has shown good agreement between polysomnography sleep outcomes, which is considered a gold standard measure in sleep research. However, it's not been validated among children. So in this study, I want to look at the validity of this algorithm among children. So my research is to what extent is the Van Hees algorithm with accelerometers similar to an overnight at-home polysomnography assessment when assessing children's sleep outcomes. And to do that, I'll be using the same sample as study 2. So this sample will be screened for any known sleep disorders and excluded if any are present. Again, I'm going to collect basic demographic information, including age, gender, family status, and socioeconomic status, and height and weight. And then participants will be asked to wear the accelerometer device for 8 days. And then on the 7th day, the participants will complete an at-home polysomnography assessment while wearing the accelerometer. So I'll compare the data from the accelerometer data and the PSG data. So measures that I will look at include time in bed, sleep duration, sleep efficiency, sleep onset latency, so the amount of time from getting into bed until falling asleep, and wake after sleep onset. So for study 2 and 3, I have refined the protocol. The procedures for study 3 have already been approved by ethics, so I have submitted an ethics amendment to include the measures for study 2. So now I'm waiting on ethics approval, and then as soon as we get that, I'll start recruitment. And I plan on having these studies finished by this time next year. So in my final study, I hope to bring all of these studies together and use these validated measures to look at the impact of children's screen use on sleep. And I also want to compare the self-reported data with the data captured by the device measures. So research has consistently shown that children's screen use and sleep are associated. However, there are inconsistent results regarding whether the type of device, the content, or the context of children's screen use affects sleep outcomes. For example, one study found that having a TV or a small screen device, such as a smartphone, near where you sleep was associated with shorter sleep time, while another studies found that children's computer use was associated with shorter sleep time, and actually found no associations between TV viewing and sleep time. So in this study, I want to have a look at these associations, and I also want to have a look at how the relationship between screen use and sleep compares across the subjective and the device-based measures. The data for this study will be collected as part of the larger study called Kid Vision. Participants will be aged 7 to 10 years old, and they'll be required to wear a camera during all waking hours across 4 days. The participants will wear an accelerometer for 8 days, and then we'll complete a self-reported screen use questionnaire and a self-reported sleep questionnaire. And so to investigate the impact of screen use on sleep, I want to examine the associations between the type of device, the content, and the context of children's screen use with the sleep duration and quality. And then I also want to compare the self-reported screen use and sleep measures with the device-based screen use and sleep measures. To investigate first, if these two measures differ and second, how the relationship between screen use and sleep compares across the subjective and the device-based measures. So for the past year, we've been setting up all the procedures and measures for the Kid Vision study. We have ethics approval and we want to start recruitment by the end of this year. I plan on finishing this study midway through next year. And then through September to December, I'll be writing my thesis and I'll be able to submit it on time in January 2023. So an important question is, why does all of this research matter? Well, our current understanding of how screen use impacts children's sleep and other health behaviours as well is limited. And to get a better understanding, we need to improve the quality of our measures. And that's what I hope to address in my thesis research. So looking at using wearable cameras and accelerometers to provide a more accurate measure of children's screen use and sleep, which then can be used by other researchers and help develop interventions and policies based on more accurate data. So thanks for listening to my presentation, and are there any questions?